So Greg, we are here at Open Source Leadership Summit.
Yes.
What are you doing here? It's not about Linux, it's about open source.
But it's Linux. So Linux is underneath all this stuff. To be fair, that is true. This is not, there's one other developer here. We're like, hey, a developer. But he's representing his company. I'm here to answer questions and talk about, I actually had to talk about licensing for the kernel and SPDX and stuff like that. And then there's also a Linux Foundation board meeting later this week.
So when you talk about licensing, what do you mean?
So the kernel is GPL version 2, right? Mm-hmm. But the kernel source tree itself has like 10, 12 different licenses in it for different things based on what it is. We recently just, SPDX is a way to identify license in one single string, one single line. And ideally, you'd be able to just grep the whole kernel tree and know the license for everything. But it turns out it's more complex. There's 6 different variants of GPL v2 text, we found out.
Oh, really?
Yeah. So in doing this research, like which GPL v2 do you care about? We have boilerplate text that is wrong in places. There's 700 different ways we say GPL v2 in the files. Out of 25,000 files, right? 700 different ways. So part of the work is to go through and clean up all that. Recently, back in November or December, it turned out 11,000 of our files had no licensed text at all. So I did one commit to the kernel tree that touched 11,000 files and added the proper...
So you have so much power?
Well, we talked about this in the kernel summit. We all got together and we're going to use the SPDX. Here's how we write it. And then after that, we're going through and cleaning up all this weird boilerplate and using just the simple, here's the line, here's what the text is. Because some files are dual licensed. You can be GPL version 2 only or GPL version 2 or anything else after that. So we just get the right list. And we're cleaning it all up. So we've got to talk about licensing.
Okay, and I think you're working with Kate.
Kate did talk. So it's Kate and me and Philippe.
Yes, there's 3 people. Yeah, because I did a story about SPD a few months ago. It was a great deal. Because people, when they think about open source, they think it's open source. We don't have to worry about licensing or compliance, but that's not the case.
Right. It's really tricky. And how do you comply? Even with the Apache and the BSD licenses require attribution.
Exactly.
How do you do that? So a really cool thing is the FSFE came out with a tool called Reuse, and you can run it on your repo, and it sucks all the license out of it and makes a manifest that accurately describes exactly what the source code is for your thing. And so people that build products based on open source can use that tool to properly know how to handle what they're supposed to be doing, what their rules are, what they have to handle. I think
FSF is totally different from FSF from US, right?
Correct.
They are totally independent.
Two different organizations.
Yeah, because I met Matthias and George Grieve, who is also another founder, and he's a very good friend. So we talked about the difference between 2 organizations. Yeah. One is like Greenpeace, they beat everybody up, and the other one is like more.
I don't know. I've known both parties very well. I am a member of FSFE.
Yeah.
I do support what they do, so I work closely with them. And now I live in Europe, so it's easier.
It's even easier. And they're doing some incredible work there.
They are. So like even just tools reuse, but then the whole public funds, public source.
Yes.
I'm saying that word wrong.
Yeah, probably it's something like that. Yeah.
That's a great initiative, and I know like the government of France has the rule that they have to release everything now.
Right.
That they produce all their data has to be even open, which is great. So the governments are changing and producing open source code in huge amounts now.
And now since you have moved to France, and a lot of kernel developers, Leonard and a lot of people, they are based in Europe. So how does it change your working? I mean, you work on mailing lists, but
it doesn't. Like I can live anywhere in the world; it doesn't matter. In fact, there's 3 of us on the kernel security team that have to live in Paris, so we get together for lunch.
You have to live in Paris?
No, that we happen to all live in Paris.
Okay.
So no, 3 of us out of the 12 kernel security people on the team, we all live in Paris, so we get together for lunch once a month. Which is kind of funny. It's just really random. But
so do you talk about kernel stuff only, or you really enjoy French fries?
We have good food, good meat and stuff like that. Okay. So, we talk kernel security stuff. We are all developers.
But I think you're a vegetarian, right?
I was until I moved to France.
Yeah, because once you,
when you can't read the language, you just have to accept sometimes what they give you.
When we lived in Belgium, because they speak French there, we were never able to order pizza over phone.
Yeah.
It was never there, So how is the experience living there versus here? Because I feel that there's much more awareness about open source and Linux, all across the board.
It is. I mean, so France specifically has the university I work with and INRIA. INRIA is the French government agency that computer science, and they've been a huge supporter of open source for the year. They supported initial GCC development. And there's a huge community of open source developers in there. They have the language OCaml, which is all open source, and that's a very French-driven language, programming language that the research communities use as well as the finance communities. So that's all open source. The universities teach on Linux, and there's a really, one reason I went to Paris was there's a really good group of researchers there that do systems development, research on operating systems that are applicable, so it's research that people can use. So Julia Lowell, who made Kernel, the tool that has fixed more kernel bugs than anybody else, and her team have done really good stuff, and they have graduate students, and they do other research and stuff like that.
And since you're there in France, are you also working with like any government organization or something like that to help them?
I have contacts within different agencies in the French government that do use Linux, and I meet with them just because I've met these people and provide advice for them. One of them created a tool, a template for the Office of the CIO of the French government that allows people to adopt an open source methodology for their company. And so we all created it with advice of lots of different governments. It was done in an open source way. The To-Do group, a whole bunch of different people came together and wrote this template up. And you can take this template, and it's been translated to French, of course, and use that as a way to have to control how open source is used. It like gives defaults of, hey, this is the licenses you should use, and here's how you deal with the community, and here's the stuff. It's a great template, and it's all open. It's part of the To-Do group website now, so I was involved in that.
Okay.
So that was really good.
Okay, now let's just switch gears from Paris and France to real. I lived there, so I do know what it feels like. For the last 1 or 2 years, one of the things that has plagued Linux world has been security. Not just Linux world, but we saw the whole Intel. Before we go there, when we think about open source, we always think, oh, it's secure, the code is open. But we have seen Heartbleed, and a lot of things happen. So what efforts is the Linux kernel community making? As Linus says, the software is bug is part of software development process. So what steps are you taking to ensure that, okay, bugs will be there, but to detecting them early or to kind of mitigate them before they actually are released and they find the way in the system? Number one.
So there's two things. There's one is a bug is a bug. We don't know if a bug is a security bug or not. There's a famous bug that I fixed, and then 3 years later, Red Hat realized it was a security hole. But the other thing is the kernel community realizes that we need to have mitigations.
Exactly.
So hardening. We need to have hardening. So there's been a huge effort by Case Cook and others to take hardening features that have been traditionally outside the kernel and get them merged or adapt them for the kernel. So that when the bugs happen, because they will always happen, you can't do anything about it. Or it didn't hurt you.
Yeah.
So like we have a simple one of when you increment a number too much, it would overflow. So the reference count, and you could leak memory that way. And now it won't, it'll stop. So I mean, there are things like that. We'll do things like that. Some stuff with protected memory and some other stuff. So that when the bug happens, the traditional old one was if you referenced 0 as a pointer. Traditionally, that used to be a security hole because you could access that. Many years ago, we made it so we changed the way the kernel was laid out so that if that happened, it was just a bug and you couldn't do anything about it. It wouldn't hurt you. So we're in every kernel that gets released, Case Cook does a little summary of all the new hardening features that are there. That being said, you have to enable them to take advantage of them.
Exactly.
So I've gone through and audited a whole bunch of Android phones recently, and some recent security bugs that we had, like that would, if you had enabled the hardening features, wouldn't have even tripped it. There's a Bluetooth bug recently that it was a buffer overflow. If you enabled the buffer overflow checking and stuff that we have in the kernel, it wasn't mitigated, so all your Pixel phones were fine. They didn't even care about the bug. But other phones that just didn't turn that kernel configuration on were vulnerable. Right. So it's part of getting into the kernel and then letting people know that they need to enable this stuff.
Yeah, that is the second part of the point, was that even if you fix things, as you gave example of Red Hat, and we have seen, and we also talked about earlier also, that the system should be designed in a way that whatever changes or patches you're making, they should be actually applied.
Yes, but yeah, they should be applied and they should be used. So we release the stable kernels every week. I do a new stable kernel. Google announced that like one of the stable kernels 4.4 they wanted to support for 6 years. And they're doing that in a way because they want device manufacturers to take advantage of this. And then what I did is I went out and bought all the top of the line phones that are based on the 4.4 kernel and see which ones actually updated. And so far only one company has actually updated their kernel. So the fact that we're releasing these kernels that are stable and update and have these bug fixes, as well as, so there's the carrot and the stick. They have security fixes and tons of bug fixes, but they have some improvements. Like we sped up out of memory handling, we sped up a whole bunch of stuff. So you get benefits by taking these updates as well. These manufacturers haven't taken them yet. They're not updated. And so I'm working through the whole supply chain of trying to solve that problem because it's a tough problem. There's many different groups involved, the SoC, the manufacturer, the carrier. But the point is it has to push that kernel that we create out to people so they actually use it.
But for the long term, you can't keep, keeping up because there's so many bottlenecks as you gave example, that.
Well, why not? So today your Android phone gets a security update a month. That'd be wonderful. Just update the kernel then.
Yeah, but who's going to do that? Google?
Google today already releases security updates once a month.
What about Samsung?
But then you got to push that. I mean, so there is a large ecosystem, right? Yeah. So if you control the whole supply chain, it'd be wonderful. But the way our ecosystem works, it doesn't.
If we just keep these consumer space, we talk about the server space where we have CoreOS, which Red Hat has acquired. They came up with a model where it's atomic patches updated. There is all
Yeah, that came from Android actually.
Yeah.
Nothing came from Android, but yes, the constantly keeping up to date and update. And if you look, even the enterprise distros, Red Hat and SUSE, even their big enterprise kernels do get updated all the time too. Yeah. But you just have to update them. But with modern systems you have lots of containers and pods and virtualizations, that makes it even easier because you're not relying on your 9s of stability for your one machine.
Right.
You can reboot this one, and update it at the same time. And that's actually made things better, easier to be secure than it used to be.
Right. But now IoT devices are there, Google Home and Alexa.
Yeah.
I heard a story on Verge that the author complained that I was listening to a music and there was an update and Alexa stopped my music and updated. I think it's a good thing that it stopped the music and updated because if it is a security patch, I won't mind my music getting stopped if the company is proactive in running.
Yeah, or do it at night, or I mean.
Exactly. If you're running a Tesla, you don't you certainly don't take over the system. But
right. So like my TV, it tells me, okay, I want to do this update. Is it okay to do it now, or do you want me to do it later tonight?
Right.
It does that. So
it does, yeah. And what about the Heartbleed and Spectra?
Meltdown and Spectra.
Meltdown and Spectra.
Heartbleed.
It's a long day.
Yeah.
7 interviews. So.
Meltdown and Spectra. First off, and the severity level of things, very minor. Okay. All you can do really with Heartbleed, Meltdown and Spectra is you can read data that you shouldn't be able to read from somebody else. You can't modify it, you can't change what they're doing, but you can get some information out of it. That being said, Intel approached this problem that Google reported in a very different way. They approached it as a hardware bug because originally it was reported that, hey, the CPU is doing something really weird. So their hardware division was in charge of managing this. And then the software side got involved very late in the process. And then the way that Intel managed it, as everybody knows, was not really that good. To be fair though, Linux, by the time the leak happened a week early, Linux was fixed for Meltdown. We fixed it on time. Spectra was another issue. We got access to Spectra, the fixes, and knew about it we thought 1 week before we had to release. Actually, it was 1 day because it got earlier. Now, the latest kernel versions are all fixed. So we fixed it all. The way Intel handled it was hard for the other open source operating systems. The BSDs were not notified.
Right.
The OpenSolaris was not notified, and that's that. So, and Intel I've talked to them, I just had a phone call with them again today. They're reworking on how they approach security bugs and how they work with the community because they know they did it wrong. So we do have a in-place process to do this, security@kernel.org. You email us, here's the bug, and we fix it. And we do this all the time. We fixed security bugs that you could arguably say was more important like 2 weeks ago than what Meltdown and Spectra was. Nobody noticed. We pushed it out, everybody got it, everything was happy. just don't know about it. There's not advertising behind it, right?
Right.
That, to be fair, Meltdown and Spectre was a very unique thing that we fix bugs in hardware all the time. That's what a kernel does. But this just happened to be a piece of hardware that everybody has. And also it does. I mean, the bug was that it was an assumption that we thought the CPU worked this way, and it turns out it wasn't. So it kind of, like the formal methods people are really interested because all of a sudden their model of what a CPU can and cannot do is wrong. So all their formal proofs for how things are supposed to work flew out the window because it turns out there's a side channel because they predict in the future and you can actually detect the prediction. So it was kind of a little side note that those people who formally prove programs are having to revisit everything.
So I mean, does Intel need a new architecture, or that's totally?
No, I mean, so Meltdown was Meltdown's fixed. That's easy. Spectre, it's just the way CPUs were designed. That they, in order to go faster, you have to look farther ahead in the future, and so in some rare cases, when you can modify what you're testing, so it's very simple. If this happens, then do that. So that do that was actually executed before the if happened. Okay. And so if you can control what that if is testing, you can sometimes see what that is.
Okay.
So you're looking, and then if you're looking from the side, you can see that. So in the kernel, or what you're doing is you're crossing a security boundary. So me as a process, I can see what another process is doing, or me as a virtual machine, I can see what another virtual machine is doing, if I can control data out there. And you can, so there's been proof of executions of how to do this. Or your browser, like you run insecure, you run JavaScript and you don't want another tab to see what that tab is.
Yeah.
So the browsers are fixed for it now. The kernel's fixed for almost all the big Spectre issues. It's gonna be a long tail of minor things where we're sweeping the whole kernel of all, is this data that comes from the user or that the user can modify, and do we need to protect from that? And we have tools that are testing for this thing in static analysis, but the false positive rate is like hugely high, so we have to dig through it by hand. But all the big issues for x86 and ARM are fixed. Other CPUs are more interesting.
So when you talk about all this security, you are actually becoming like a security expert within the kernel community. Are there do you have some big maintainers there? So are there like some maintainers dedicated to doing this, or it's like whether it's Linus or you or Andrew or whoever, everybody's doing everything?
So we have a security team, right? Our security, so like the kernel security team is just a bunch of people who know the core of the kernel. When we get a report, we then drag in the domain ownership. So say there's a bug in the sound subsystem. We say, hey, Takashi, there's a bug over here. So we grab him and pull it in, and then we get the local ownership. Sometimes on the security team, we had some areas of the kernel that were always grabbing the same people, so we made them just part of the security team to make it save that extra hop. So it turns out a lot of the core kernel people are on the security team. We just fix the bug and everything's fine. But I mean, all parts of the kernel have to be aware of these security issues because we are a trusted environment and you have to protect it. So these are just, we have things in place that once we fix things, we can put them in our static analysis rules, and that way we never get it reintroduced. So we do things like that. And then on the other side is like Case Cook and his work are adding hardening. So that's the other security type of thing, and they're adding features to do hardening and other bugs like that. Or fix other things like that.
As Linus said in the previous, that we want the hackers to join us instead of attacking us. So how to kind of either encourage or incentivize people so that instead of kind of, even if there are no such attacks or where we have seen people are exploiting it, how to encourage people to actually become part of the security community where they help the kernel community instead of.
Well, we always need help, right? And so we have. If you want to work on the kernel, you can usually get a job doing that. On the flip side, there's some companies that offer bounties for notifications of security bugs. I know Google does that. So we get a lot of reports from Google where somebody's reported a bug to them, and then we look and see, and they think it's a security issue, we fix it or not. So we get that a lot. So companies are willing to pay for that. So that there's other projects we have so Coverity is a static analysis tool. For years, they've been running on the kernel, but nobody's been fixing all the bugs it finds. So the Common Infrastructure Initiative from the Linux Foundation funded a kernel developer for a year to go through and just fix all those bugs. And he's doing an awesome job, and he's got a job for a year, right? So to do all this kind of stuff and work through and fix all these bugs. Actually, I need to get him to do some of the Spectre fixes to think about it. So we have, if you want a job to do this type of work, we have plenty of companies. Any company would love to hire you. I know some people who have started off fixing bugs and then get hired by companies just to do other development and things like that.
Anything else you would like to talk about? We covered some, I mean, I can talk to you for hours and hours.
Sure.
But
we have any other questions?
But we have,
I don't have anything specific. So that's been consuming my life, is getting all the updates to all the backported kernels for that. But just, make sure you update your kernel. Take the update. Yeah, if you make a device, make sure it's always updatable.
Right, exactly, yeah.
So there's some interesting things with kernels are wanting to be supported for a very long time because they're going into infrastructure. Like the Japan is putting them in streetlights.
Yes, we talked about that.
So that's a fun one. So making sure those kernels are stayed up to date and that we can test them properly in order to be able to push them out safely. I've been working on that, talking to lots of chip manufacturers that way.
Are you bored of this work, or are you?
It's always something different. It's always something different, right? And I still do the normal development and as far as review of the stuff that comes in, but no, it's not bored. I haven't got bored yet. It changes all the time. There's always new hardware. There's always one really, really neat thing about the Google thing with Spectre and Heartbleed is it opened up a whole new research into these type of side channel attacks. That was a brand new. It was building on the prior art that people have found, but it was interesting in that it was, hey, there's something brand new here. So that's kind of fun.
When I said, you're bored, what I meant, but you have been doing this for so long.
I have.
Yeah, and but the thing is that excitement is far from over. The new use cases are coming out. IoT is coming, and so much is happening. And everybody's using Linux for. Even Microsoft Azure is. There's
Azure's a ton of Linux.
Their networking switches. It runs on Linux, so a lot of more work. But if you look at the core kernel community, I'm going back to the question that people keep asking, is still the same people, you, Linus, and all those people. So how do you attract new people?
We have new people all the time. So every kernel release, we have 150 to 200 new people every 3 months. That's a huge number, right? Of people, and we have 2,500 people release. I don't remember the exact numbers. But so we still have a huge number of new people every year, or every release are attracted. And there's a side thing. So when people ask, we're getting older, right? New people. Is that a bad thing if people with experience and age are still working on a project because they still know what's going on? Or no, I think that's really good. Look at the networking team. They've been doing networking for 20 years, right? That's a huge body of knowledge, and we want those people. That being said, we have new people coming in to show their ideas, or we need the help. And we get new people in all the time. We have tons of work to do. We have tons of areas of the kernel that don't really have a maintainer. And we always need the help. And we're still attracting them, as long as we keep attracting new people.
With all the security things coming up and the explosion, how much later, what is your big concern when you look tomorrow that, you're still worried, that we should, this is something we should be...
What do I worry about? What do I worry about? Worry about legal stuff, unfortunately.
What do you mean by that?
Legal. So we've had the copyright troll problem recently.
Oh, yes.
So, which the latest thing just happened today in Germany, that the current person who was doing that withdrew his appeal. So he gave up on his latest one, which was interesting. I helped out actually with that defense a little bit, and I put in, it's not a friend of the court, I put in a little deposition saying, here's how Linux is developed and things like that, questions about that. Because what he was proposing was not really the way Linux is developed. So there's legal threats that are, and trolls from outside our community are always my big threats, right? What that can hurt us. And I always do joke, Linux is so successful and is everywhere, and so the only thing that can hurt Linux is Linux itself.
You have said, yeah.
So what does make me worry is if we mess up, if our development model crashes, if we do something stupid and we push people away, if we're not accepting still new developers, if our rate of change can go down, it's fine, our rate of change is so high, but if we're doing stupid things that we're driving people away from Linux, because it's our fault. And that's what I worry about. And so every year at the Kernel Summit, we reevaluate what we do and we talk about our process. And one of the things was we need to do licensing in a better way because lawyers are reviewing this stuff. This makes their life easier and they can make sure they're compliant with our license easier. Great, here's one thing that can help them out. New developers, we look at that all the time. Yeah. So as long as we're still doing things well, that's what I worry about. And the external legal threats.
Right. I mean, this could be off-record question. I'll just ask you based on your opinion. Then you said, not to turn people away, and sometime on mailing list, Linus, he has, his own way of saying things. But what people, I'm not defending him, but what people forget is that that treatment is reserved only for the high-level maintainer, the top maintainer that he trusts, fully. So it's more like you're sitting in a boardroom with, let's say, Donald Trump, and there are three advisors, top advisor, So there, the language can be any way it can be. So I don't really know how much you want to comment on it or not, but what I'm saying is that I see people misinterpreting, because I've met him with the new people. He very friendly. He explains things. So do you want to comment on that or not?
So actually, this came up at lunch today with a group of people. It's really hard to get Linus riled up. Mm-hmm. So in the kernel community, we have one rule, and the one rule is we cannot break user space. Mm-hmm. We made that guarantee over a decade ago, called the Cambridge rule, because we happened to be in Cambridge at the time. So Linus yells at you when you break that rule on purpose. If you break that rule accidentally, we're all human, we fix it, we move on, or we break it and we can't figure out how to fix it, we fix it and move on, or we do something. But Linus will yell at you when you're obstinate and you're saying, I'm breaking this and I'm okay with breaking this, and that's not okay. Mm-hmm. And it's a high bar to push him to yell at you. Mm-hmm.
Yes.
But some people are, developers are not the most feedback-friendly people.
Exactly.
That feedback loop is not always there, and email is a very tough medium in which to convey tone and expression of something, and sometimes you have to be very direct. But if you are if I do something stupid and I break something and I know I'm breaking something and I'm insisting I'm allowing it to break, Linus will yell at me, rightfully so. Mm-hmm. And that's okay. And it's always reported, might say, because conflict is easy to report on, and people like reading about conflict.
Exactly, it's more juice there.
It's juicy, and like I always said, you should see emails for internal companies, right? Mm-hmm. I've been developers. It's just totally separate. I've been in meetings at some companies where people cry, right? Some major companies used to have conflict as their major source of how they would resolve problems. Conflict was the way they resolve. Exactly. So so that's not a good thing at all. But I'm saying what we do, everything we do is in the open. And our tens of thousands of emails we all write.
The big problem is that everything is in open, so your frustration is also in open. So
sure, it's in the open. But also, if I do something stupid or Mara does something stupid, we know each other. We drank beers, and it's friends. So it's like I also use the term: you don't put a live microphone on a Major League Baseball or a Major League Football manager because he's yelling at his players, right? It's professional. Oh yes, I know I messed up. You're right, because they told me that, and I can take that for what it's meant to be. But we're doing it in public. Right. And it's not the Little League. You don't yell at the Little League.
Yeah, exactly.
That way.
Since we do have some extra time, I wanted because I talked to you earlier, but that was not on the video format. How did you start your Linux journey?
I've told you this before.
Yeah, but it was not on the...
That's fine. So I used Linux many, many years ago. I come from the embedded world, so I used Linux in a product we made where we were using SCO. Linux running Oracle. Oracle came out on Linux. We're like, let's try and install it, and it ran wonderful. Mm-hmm. So I'd used Linux for a while, and then I was working for a company that we made barcode scanners. Mm-hmm. And then I was trying to test out my device with USB on all sorts of different operating systems. I accidentally made a barcode scanner that showed up as a 102 key mouse. So the 102 key keyboard. Linux didn't like that. And Linux didn't have a working USB stack at the time. So I saw this code and I was like, hey, I can contribute, and I fixed some bugs, and then it was fun. And then I've been messing around with it a while, and then my wife was going away taking our daughter to visit a friend, and she said, hey, why don't you play with Linux this weekend and write that driver you've been talking about? So I had this little weird USB to serial device. USB to serial converter, because I dealt with serial all the time, and I wrote a driver for it, and I submitted it, and I wrote it, and then I learned from the Linux device drivers book, which I ended up being a co-author on many years ago later. I submitted it, and then instantly, I swear, within 5 minutes, somebody wrote back, oh, this is wrong, this is wrong, this is wrong, this is wrong.
And you were happy.
But I was happy. I was like, yes. So as somebody who, as a programmer, I know I'm always going to have to keep learning, right? And as you have to keep learning in order to get better. And constant state of change, you always have to keep learning and changing in order to adapt to the world. So I was like, yes, I didn't know about S&P, multiple processors, what's locking, and what's this? And oh yeah, I guess that is totally wrong. But that review process I always liked code reviews, and because you can get better. And so I didn't take it, and you have to learn how to get rid of your ego, and I can say I didn't have that ego, and criticizing my code was great. And I learned from that, and I did better, and I wrote that. And it was fun. And I had fun doing that, and I wrote drivers, for USB for a while, and then I realized more people use the stuff I gave away for free than the company I worked for, because the company I worked for wasn't all that successful at the time. And then I got a job doing Linux security stuff. So I started off in the security world.
Oh, okay.
And I helped write the first Linux security layer many years later, but a hot plug and stuff like that. So I've been involved in security for a long, long time. Yeah,
right.
So.
And how much influence do you have on your own kids? Are they all software developers? Or?
No. My daughter's, no, she has a degree in public health, and she wants to be a doctor, so she's applying to medical schools. My son, he knows how to program. He learned the basics. He's now 13, but the interesting thing is you learn to code and Code Academy, you learn the basics and Scratch and things like that. And then after you get past the basics, there's nothing to do.
Yeah, exactly. Yeah.
So it's like, and the same thing with the kernel. You have these basic tasks, but there's no intermediate tasks. And finding a project on which somebody to work on is hard, because when there's Minecraft, you can build things and go away, and that's a good distraction, right? I didn't have Minecraft when I was learning how to program. So there's so many other distractions that coming up with a solid program to make that hurdle to the intermediate stage is hard, and I haven't figured out that problem. So he learned the basics, and that's good. And everybody should learn the basics of programming, just for whatever job you have.
What do you have? What kind of hobbies do you have besides Kernel?
I used to, when I lived in the U.S., I built a kayak, a wooden kayak. Yeah. Living in France, I don't have a wooden kayak anymore, so I really don't have any hobbies. Cooking, don't know. Travel. We travel a lot more and see different parts of Europe. It's fun.
Right. And what was the reason why you moved to France?
So I'd worked with the university originally, and INRIA. They did that. I had gone over for a 3-month stay and with the family, and we realized that, and we wanted to move anyway. And so we thought we'd try it a year, and because I can work anywhere, because it doesn't matter. And actually, being in Europe worked out really well, because I've done a lot of work with some German companies and things like that, and going and visiting them is much easier than flying across the pond. And I've gotten to visit ARM in Cambridge, which is really easy. And then we stayed a year, and we renewed our visa. We want to stay longer. So,
when you mentioned the German company, you had been to SUSE, and Tumbleweed was one of the projects that you started, and now it has taken a totally different shape, where it's playing a very critical role in the whole SUSE strategy.
Yeah, I'm really happy to see that.
Yeah, so what do you think about it?
I love that model. That continually rolling update model is I always thought was a valid model for what a lot of people needed, because you see people, especially on doing the web stack, and now containers are still that same model.
Yes,
you want to update that, and you want to run the latest version of Ruby or latest version of PHP, and constantly update, versus the old enterprise model where you backport things and you update on a 2-year cycle and whatnot, which works for some environments. And the old traditional Unix model and the old traditional Windows model was that way. I think the world changes faster, and you want to do different things, so I always like the rolling release. That's my opinion.
I fully agree. I run rolling release, so I mean our bodies are rolling releases, right?
Yeah, and also it's harder. I've seen companies upgrade from major Debian release this or to that, and it's all this harshness all the time. Like, I have to figure out all these changes that just happened, versus if I have a change a week, I can roll with that, and I can figure it out and move on and do it. Yeah, it's much easier, I think, to do that. And now with containers and Kubernetes and managing these things, it makes it much easier to push out updates and keep things more up to date in a fashion that way. I like that a lot better.
And because I also use Arch Linux, but I prefer SUSE is Tumbleweed, because what Richard Brown says that it's tested, so that's kind of contrary to what rolling release is, because you
can always do a rolling release and test it.
Yeah, that's why he said it's a well tested rolling release versus whatever code is coming, just throwing out. So I love it.
It's always like I say, you should always update your kernel to all your devices, but test it. Always test it. Yeah, because I test it in what we can test things for, which our tests are getting better and better and better. Lenaro is doing actually an awesome job with testing stable releases on real hardware and putting a real load on them, not just build and boot.
Exactly.
So they're doing a great job with that. So test for your environment, and because you're always going to use it in a different way. and then you can push it out.
Yes.
But test.
Test.
And if you can't test, then you have a problem no matter what. If you update this year or 3 years later.
3 years or 5 years later.
Yeah, so you need to build your systems in a way that you can test. And in the kernel, that's been an interesting thing is it's implicit that when we ever add new features, like new system calls and whatnot, that we add tests with it. Because we don't know if the feature you're adding is right or not.
Right.
So, and like some of these backports, when we're backporting these big security features backwards, I'm kind of like pushing back and say, how do you test this? And they're like, well, we didn't test it, but it built. I'm like, okay, we need to actually test this to make sure that it did work and to validate that. So it's test and validate. And so we're updating LTP, which is the old Linux test project. For years was stagnant. And it had a bad reputation in that there's a lot of false positives in it. So it was always, is the test wrong or is the kernel wrong? And most of the time it was the test. A lot of people are now finally, that's been revived, and they're pushing patches to it, and they're updating it for fix all the false positives, and they're adding new features to it, so they're going to test more and more of Linux. And now it's running in Lenore's testing, and it's really good. Google's doing some testing in that area. So we want to test all these updates because the kernel does move very fast.
Right.
So we want to make sure we are at least not breaking anything.
Right.
So that's added to our test infrastructure. And the 0-day bot from Intel tests every commit that we make to the kernel, and it's running all those tests on those as well. They have a huge list of tests that they run on every tree and everything that before it even gets to Linus, and it has to pass those before it gets there. And testing is very, very good.
Well, we were talking about Tumbleweed. What are you running?
I run Arch.
You run Arch? Oh, so you're a fellow Arch user.
Yes.
I actually wrote an Arch tutorial. It's become so popular because people want to try it. And because once I went Archway, it was just like hard for me to. Though my Plex server is almost always broken because I use the Arch user repository or whatever you say it. But it's fun,
Yeah, Arch is good. I mean, I've resisted really hard. I don't want to be a developer of yet another distro, but. It's nice just to be a consumer of a distro that is always up to date. I have had problems where Arch updated its compiler and the kernel I couldn't build things, so I had to make sure the kernel could do that. But that was fine. Yeah. That was my fault.
Because as a journalist and as a user also, I like to stay on latest packages or whatever is there, so it helps me. I don't have to wait for a distribution I don't understand why they have to wait. When the project is open source, your distribution is open source, why can't you work in advance, and test and do everything at the early stages?
Yeah, if you look at the Debian release model, it's the old traditional software release model, and again, it works. So one interesting thing about Spectra and Meltdown, I want to say Heartbleed, was that the original Intel approached the enterprise distros, and so Red Hat and SUSE and Canonical were all notified before the community. And the problem with that was the majority of the world does not run those kernels.
Exactly.
So the majority of the world, it turns out, runs Debian, and it runs their own kernel from kernel.org. So like all the cloud hosting providers and all that stuff, like my cloud hosting provider runs just the kernel.org kernel, and it's awesome. So that was the big problem with Meltdown and Spectre is the 1/3 of the world's kernels were safe, but the rest of the community was not notified in time, so we couldn't get stuff out to other people. So one thing that education-wise is dealing with the old model of companies only dealing with other companies, that's not necessarily true. You have to talk to the community because the world runs on stock kernel.org stuff or Debian. Actually, Debian is everywhere.
Right.
So that old model of the slow release for Debian does work. And they're really good at backporting stable stuff or patches, and they go through a ton of work. I don't like it because so that model, but you can always run Debian bleeding edge. But it does work for a huge computing model, and people are used to. So it's fun, and it's kept up to date. And the Debian guys do wonderful security stuff. So everything they're doing is kept up to date, and it is rolling with the security fixes. But when you upgrade to a bigger release, it's kind of hard.
Then because of that, Even I have not updated my Linux server to the latest because I was worried that something will break because I'm running a couple of sites there with a lot of customization, so I didn't bother, because it's still supported. So when it'll be out of the end of cycle, then I will update it. So I wish I ran Arch and things there.
So I run Arch there.
Yeah, because now I am like too busy with other things that I don't have time. I will like at one point if I was running originally, I just open SSH, update it, and done. I don't have to worry about anything.
So the cattle versus the pet model. So
Yes.
I think you have the same problem. So my server instances are my pets because they're carefully
Yes,
tuned and
exactly,
whatnot.
yes.
But if my laptop disappears today,
I don't
it's
care.
the pet and,
Yes.
or it's cattle, and I can back it up from my server.
Everything is already, nothing remains here either way. Everything is backed up.
Yeah, everything's secure, and if it's gone, it's fine. It breaks. I move on to the next one, and actually less than an hour, my new laptop's up and running fine.
Right.
So I need to make that so my servers are treated that way. And actually, Kubernetes and the way you handle containers, I've been starting to push some things to that, and it makes that much easier. So that model is much powerful. I have a big build server for my testing for Linux kernel, and it's now. I'm overusing it. So my builds are going slower because I'm doing so many builds. So I think I need to just split it out and start using the cloud more and make it.
So what kind of machine are you using? Can you give us know?
I don't know. It's some big. It's in the data center we have.
Okay.
So they bought me I got a big giant Xeon build server.
So do you go and sit inside just like science fiction movies, sit in a big data set?
No. So when I do a commit to the stable tree, I have it commits and it pushes out and it fires off a test build. And I get a report from email, depending on the load of it, within less than 5 minutes.
But how secure is that server or data center?
It's just I'm building publicly available code.
Oh, okay.
I'm just building it. It's just a build, you know what I mean? And it's secure, yeah.
How about Linux machine? What kind of machine he uses? He also uses the same
Yes. I don't. That's just my test builds to make sure I didn't break anything.
Okay.
So I've committed everything to a public tree anyway.
Okay.
So it's like I run test builds that make sure that I didn't break the build, didn't break any warnings, and things like that. That's all it is. It's just a test load. I could run it on. I need to run it on a zillion cloud instances and go faster. So I run on my laptop mostly. But I don't have any secrets, right? I got no secrets on my laptop.
I don't know.
Yeah, no. I mean, it's just. I mean, when you're doing open source development, the patches, the changes that are coming to us are coming in public.
Publicly, yeah.
So, with the exception of the tiny subset of security patches, which we only keep secret for a week anyway before we push them out. So there's nothing. It's like secret there. My wife's always saying the Russians are going to get into your laptop. Yeah. Well, it's fine. It's
like just James Bond movie, aluminum case laptop with a chain on your head.
It's all secure by that. No, we have two-factor authentication so that when Linus and I push to our public repos, that is two-factor authentication. So we do that. It's so that's secure. We encrypt our laptop drives and things like that. So we have best practice. Actually, so Constantine, the sysadmin for Kernel.org, has published a wonderful resource on how to do a secure Linux machine, a developer machine, and given it all to kernel developers, it's public. The sysadmin guide for how to do a secure sysadmin system, because all the Linux Foundation sysadmins have to do this. And now he did a guide on how to do good GPG key handling.
Okay.
And how to rotate them properly and secure them properly, and what the good methods of care and feeding of your GPG key. Because we use GPG for when we do releases, we sign them, push them out that way. So he's been publicly making that available to everybody, and that's a really good resource.
What was this best practice adopted after that one thing happened where the LKML, the Linux archive was kind of compromised? I think it happens.
So lkml.org is just a random website that gets an email archive of the kernel. So that has nothing to do with our development. Our mail server is fine. So that was just think of it as a copy of all our public email. It was just a mail server. So it's just a site you could search. So
I know, but there was something, because right now it's a long day, I've forgotten, there was something that was compromised and you guys had to rebuild everything, or...
Oh, when Kernel.org broke down many years ago, yes. Yeah, Kernel.org got compromised many years ago.
So was this best practices adopted after that? Or?
So we have redesigned how Kernel.org works, amazingly. And he gave a talk on, a couple of years ago at the Kernel Recipes Conference in France, on how Kernel.org is designed, and when Linus does I want to push a release, here's the steps of how that. So it's all publicly documented of how we do everything. And there used to be a Raspberry Pi involved in it too. Yeah, the Raspberry Pi did some of the key signing, because when we do the releases, because that was a secure little almost air gap system. I was told that the Raspberry Pi is not in use anymore. So I don't know what replaced that, but it's something else. But there's the steps that are involved with our two-factor authentication system and whatnot. And Constantine comes from the Fedora community. He was the sysadmin for the Fedora, and he's amazing. And the other kernel.org sysadmins are great. So they built a system that we documented how it all works, and it's really, really secure. And like he says, he wants to be able to make it if something happens to him, or we need to pull we needed to revoke his access, we can do it like that, and it's still a secure system.
Okay.
So it's built, and it's public. The design and implementation of all that is public as well. So other people can use it for their secure systems.
Anything else? I think we covered a lot of topic today. Yeah.
It's fun talking to you.
It's fun. Yeah, it's always fun talking to you all the time.
Good topics.
Okay.
That was a wide range.
It was, yeah. We went from your own childhood days to your kids to friends to from kernel to security to Android. Yeah, we covered a lot. Thank you so much. It was nice talk. It's always fun to talk to you.